Never quite sure when it starts the stream. Hey everybody, it's Smitty here. I've been kind of quiet for a bit. I've been off the air for a little bit while I was working on things for Maker Faire. One of these days I'll get around to putting a webcam over in my build area over there so that I can actually stream some of that stuff instead of just the computer stuff. But I have been busy this time. I have not been resting on my laurels. As you can see here, this is kind of the version 1.0 of the satellite optimized amateur radio that I was working on last, or SOAR, as I've been calling it, SOAR. I can't remember who it was on Twitter who gave me that recommendation for a name, but I quite liked it, so I'm using it. So this is SOAR, the satellite optimized amateur radio, and this is version 1.0. I learned a lot about this on this board, and I've got some major changes I need to make to it. And that's what I'm going to be working on now. Architecturally, it's going to be basically the same, and I'm still going to be doing kind of a flat board, not in a case development environment style design and layout. So I'm not going to be bumping the version to 1.1. But I am, I'm sorry, to 2.0. I'm only bumping it to version 1.1 because it's just kind of some enhancements to kind of the existing architecture. But as a quick reminder, for those who may not have remembered, it is a radio that is meant to talk to amateur radio satellites. So there are two main things that you have to do when you're talking to amateur satellites. One is that you need to be able to transmit and receive at the same time on different bands, VHF and UHF, but you need to do full duplex so that you can hear yourself coming out of the satellite. It helps you when you're transmitting to be able to point your antenna and know when you've got the best signal strength, right? So that's one thing. So I've got two modules here, a DRA 818 UHF and a VHF. VHF and a UHF. And I can operate these two at the same time. And as long as I do proper filtering on the out... My microphone's got some droop. As long as we do some proper diplexing and filtering on the outputs, they should be able to operate concurrently at the same time. The other thing you need to be able to do when working satellites is adjust for Doppler shift. As the satellite is rising over the horizon, it's coming toward you incredibly fast enough that the frequency you're operating to that repeater in the sky is actually up by about 10 kilohertz. Similarly, as it's receding on the other horizon, as it's setting, it's moving away from you just as fast, and so you have to Doppler shift down by about 10 kilohertz. I have a microcontroller in here that is adjusting the frequency of these two modules over a serial port, and so it can handle all of that Doppler shift for you. Everything else is just basically a user interface. I've got a real-time clock up here so that it knows what time it is so that it can do the Doppler shift, so it'll know where the satellites are in the sky and it can do the Doppler shift for you. Otherwise, I've got a small OLED display, I've got a little encoder wheel, some buttons for push to talk and for the UI, an enter button and a back button on the UI, volume control here, microphone and headphones out. It's meant for like plugging into like a gaming headset, or I've got a El Cheapo gaming headset here that I got off of Amazon for $15. It's meant to work with that. And that's one of the problems I ran into that I'll talk about. And then it has an external PTT connector here that you can use to put a button on the handle of your antenna or a foot switch or, something. And so that's what we did. And then there's some audio mixing and wackiness in the middle. Now, some of that audio stuff is where I'm going to be doing a lot of my changes this time around. But I'm also going to swap out the microcontroller for something a little bit more powerful. This one is a Arduino Pro Micro, which is a 32U4. Kenneth has left the call. Well, that's a bummer. It's a 32U4 Atmel AVR platform. They're great little chips. The problem is they've only got 2K of RAM, and that OLED display right there uses 1K of it as a frame buffer. So it just doesn't have enough horsepower. It just doesn't have enough RAM to do what I really need it to do. So I'm going to upgrade that to a Teensy. Teensy is a great little microcontroller designed by a guy named Paul. Forgive me, I don't know much more about him. I met him at Maker Faire, actually at the Osh Park after party just this past weekend. His Teensies are great little ARM-based M4 microcontrollers, I believe. I'm looking at the Teensy 3.2, which is a relatively small. It's about the same size as that. I think it has a few more pins. It's a little bit longer, but it's about the same size as the Pro Micro. and but it has a heck of a lot more resources internally. I think it's 32K of RAM instead of 2K. It's like 256K of flash. It's a much faster CPU, much more powerful CPU. It doesn't have floating point, if I remember correctly. The M4 does not. I think the M4 Plus is what adds the floating point. But it's a heck of a lot more powerful. I don't need the CPU horsepower, but I kind of do need the RAM. More importantly, it has the real I/O. It's got a lot of I/O on it for things like the serial ports. So talking to these modules, the DRA modules, you talk to them over an UART serial port. And I've got one real UART on the Pro Micro, and it talks to one of the modules, and then I'm running a software UART on the other module. I would love to be able to have those hardware enabled in hardware. So anyway, I'm rambling now. I've got some changes here. I have made some notes. Let's see here. Yeah, so I'm waiting. I've got invited a few people into a hangout to come heckle me. They haven't shown up yet. Kenneth was here for a little bit, but he had to take off. I have some notes. Where is it? There it is. So these are some notes. I don't think you guys can read them, but I'll read what they are. And we can actually terminal. Nope. Profile preferences. Can I make that big? Go big. Yoink, 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 yoink. Let's see if I can make this easier. Wow. Is that a little easier to read? Okay. Oh, and it did it for all my terminals. That's lovely. Okay, and that's a horrible font to read too. Anyway, so one of the things I did wrong was can't get my audio to chooch. We may need to play with that someday. I'm not about to leave for errands. Okay, so Kenneth wasn't able to get his audio to work, so he's not going to be able to join me today. But I'm sure we'll find somebody else, one of the other folks I've invited to come heckle me. So one of the problems I had was that I got the power and ground backwards. I don't know if you can see it in there on this connector for the OLED. So I actually had to lift that connector off the board and twist the power and ground so that I didn't blow out my OLED displays. So that's something I need to fix. The other problem that I had is, let's see here, this amplifier. So that is my audio amplifier. It's an NS8002. And you'll note that it has a positive and negative output. So it is not ground referenced. It is push-pull. It has opposing signals coming out of it, which is a great way to get more power out of a low-voltage amplifier. But unfortunately, when you plug that into a cheap Chinese headset, which expects your audio, your headphone audio to be ground referenced, and shares that ground between the headphones and the microphone, you are now effectively tying one of those outputs to ground through the microphone, which does bad things. So I had, damn it, I'm dropping things all over the place. I had to bodge up a connector here. You can see that connector is kind of off the board, and there's a big electrolytic capacitor right next to it. I had to basically connect off, let's go back, there we go. I had to lop off the positive side of this here, disconnect that, this wire here. I had to connect this side, which is the sleeve, to ground. So I ran a ground wire over to another ground point on the board, ground reference the headphones, and then this part, this lead right here, I had to disconnect those two resistors, and I needed to put in a big electrolytic capacitor here to block DC, because otherwise these things are DC biased. They're up at, VCC over 2, so 3.3, or 1.65 volts, whatever. So whatever the half rail voltage is, had that much DC voltage, and if I didn't put that big electrolytic capacitor in there, it would be trying to pass 1.6 some odd volts through the coils on my headphones, and that's bad. You never want to do that. Hey, Austin. Trainman419 is in the chat room. Okay, you know what I'm going to do? I'm going to do it this way. Pop out chat. And I am going to come over here. Forgive the... Where is it? What's that called? That one? Yes. Haha. Okay. Hey guys. All right, so I got Dave McKay and Trainman in my chat now. So that's good. Let me do that. Make that a little bit bigger so we can read it. Forgive me for doing all of this live on stream. So what are we working on today? Well, Dave, well, I'll go back to at least a little bit of the beginning. You may have to go back and rewatch the beginning of the stream. The short version is, here is my satellite optimized radio version 1.0, and I got a lot of problems with it that we're going to go in and start fixing today. So let us find that one. Okay. So this is the list of problems. So short answer is, I have an echo? Crap. Does that make the echo go away? Check 1 2, check 1 2. Did that make the echo go away? Dat echo. Did the echo just start, or has it been going the entire time? Yes, that made the echo go away. All right, so Hangouts is doing something funky. Okay. Well, 5 by 5. I got faith. Get it? Faith? 5 by 5? Never mind. It's a Buffy reference. Oh, you people. Okay. So, ground reference speaker. The echo came and went a few times at the beginning. That was the worst. Oh, lovely. Okay, so my worry is that it's something from Hangouts. So I may have to, I don't know how I'm going to be able to get other people's audio from Hangouts without my own audio. Because all I did is I faded down the desktop audio, but that's going to, I wonder if I can make that come from a particular application. Monitor, built-in audio. Nope, I can't. Damn it. Okay. Well, I'll figure that out. Okay. So ground reference speaker. So I was sending a bunch of signal to ground, and that caused bad things. So I need to go change to a amplifier that uses a ground referenced output. In theory, I could continue to use the NS8002, but it's kind of inefficient to do so in this way. So I was actually looking at some alternatives, and the LM4880 looks like a good alternative, and it's pin compatible for the TPA 6111A2. There are a bunch of headphone amplifiers by TI that I like. So the 4880 is one that I bought some of. They should be on their way before too long. Oh yeah, I also they have a shutdown pin, and they said ground is what did they say? High is active. And of course, the question is whether that's active on the amplifier or active on the shutdown, and I got it backwards. Active apparently refers to shutdown, not to the amplifier. So I tied it to high, which made it active, which shut down the amplifier. So I had to pull that pin and bodge it. Stand by. Hello? Hello? Yes, who is this? Okay, I don't accept phone I do not accept phone solicitations of any kind. Take my number off your list. Do not ever call me again. You guys, that gal is lucky that I am in the middle of a stream, because otherwise I like to fuck with them a little bit more than that. Anyway, so I took a note that if I'm still using the 8002, that I would that I need to take care of the shutdown pin, which I'm not going to. So, not a problem. Okay. So one of the other things that I thought about after I sent this board to Fab was that I would love to be able to have a mix of both the microphone audio and the audio coming from the radios sent off to a line level source that that you can hook up to like a phone or a recorder or something to be able to just record the entire session, the entire pass. So I want to be able to do that. Remove the 4066, which was an attempt at Trainman says he likes putting test points on things where you're not entirely sure what they're supposed to do. Yeah, I did put a lot of test points, just not that one, apparently. Excuse me. So I want to remove the 4066, which was originally an attempt to be able to switch which headphone output I was listening to. That was before I realized that we had the ability to set volume in software. So what I'm going to do instead is I'm just going to mix the headphone outs from the radios very simply, and then I will do all of the switching in software. I'm just going to turn the volume all the way down on the one that we're not using. I want to upgrade the micro to a teensy, and there are lots of reasons for doing this. For starters, got a hardware UART, which is nice. It has a third UART that I'm going to expose to connect to a GPS. I'm probably not going to bother putting an outline on the board for a GPS to solder in. You jackass, Kenneth. Hello, would you be interested in buying generic service from this unsolicited text message? Press 1 to speak to an operator now. Here's my 1, Kenneth. Okay. Now he's heckling me on my wrist. Oh yeah, so I kind of don't think I want to put a outline on the board. Yeah. Thanks, Dave. Don't encourage him. Okay, fine. Go ahead and encourage him. That's why I invite him to these things. I don't think I'm going to bother putting an outline for a GPS on the board for a couple of reasons. One, I don't really know GPS modules. I kind of don't want to do the research right now to figure them out. I don't know which one I want to put on there, so I'm just going to leave a power and UART serial port header available so that you can rig up an external GPS. And I'll get into why I want to be able to allow a GPS later. Other thing about the teensy has a built-in RTC, so I can remove the one on the I2C bus, which will make things a little bit simpler. The teensy also has really good audio, or analog DACs and ADCs. So I want the teensy to be able to generate and detect audio on the radios and in the headphones. And so ideally, it has a DAC output, and I'm going to send that DAC, and I'm going to mix it in with the microphones and be able to send that off to the radios. The idea being that it can generate signals, like maybe packet signals, it probably won't be able to do MFSK stuff, so you won't be able to do some other stuff because there's too much audio processing in these modules. But in theory, in the future, if we get a module that has a much closer tie to the modulation and the demodulator, the detector and stuff, we might be able to do some like high-speed packet or some other things on it. Regardless, I kind of want to be able to mix that in there. It's easy to mix a signal. I'm already having to put an op amp in the mic line for reasons I'll get to in a bit. And so as soon as I've already got an op amp there, I can turn that op amp into a mixer and I can add more signals to it, no problem. So I want to take the output from the DAC output from the teensy and mix it into the mic signal. And then have another PWM output and mix that into the speaker signal. So I've only got one DAC output, and I don't want to assume that both the radio modules and my headphones are going to get the same audio. And so the PWM output into the speaker signal might be used for like beeps or feedback from the UI or who knows what, right? Regardless, it now makes it so that the microcontroller can send audio to both the user and to the radios, which will be cool. And then similarly on the ADC side, send individual audio outputs from the radio modules to analog inputs on the teensy. Now the teensy doesn't have a good audio quality ADC, but it runs fast enough that you can probably sample those and get decent, at least telephone quality, 4,000 times a second, 8,000 times a second kind of sampling. At least I'm hoping so. And if that doesn't work out, then I may later on put like a small low-cost codec on it, ADC, DAC chip, and connect that into the teensy. But I do like the idea of being able to get audio in and out of the teensy. The other thing, excuse me, is that since we have enough I/O pins, I want to put a micro SD card slot on the SPI bus. Stand by. Module dropped earlier. I started looking a little bit at SD card slots, and I kind of want to keep it simple for now, so I'm going to use a little tiny breakout board. Man, there's not a lot of light there, is there? I'm going to use a little tiny breakout board. These are available from, from China, from Adafruit, lots of different things. But it's basically an SD card slot on one side and an SPI bus on the other. SD has multiple different protocols it can talk, but one of them is just SPI. It is not the fastest available option, but I don't need speed on this. So, let me talk about why I want to do some of this stuff. So we're talking about, I've mentioned wanting to put a GPS on there. I've mentioned wanting to put an SD card on there. The combination of those allows us to, rather than having the user plug in what's the rise time, what's the set time, and the center frequencies, we can now have like Kepler database, right? A database of all of the satellites and all of their orbital parameters, and allowing the teensy to go figure it out. So right now, I go to GoSatWatch on my phone, and I say, when's the next pass of, AO85 or SO50 or the ISS or whatever I want to talk to, and it goes and figures out all the math and it downloads the databases and tells me what the rise and set times are and all of that fun stuff. I can now put all of that on this micro. If we have something that has an easy way of getting data in and out, I mean, the micro itself has enough storage. I can probably do it entirely in the micro, but there's no easy way of getting data in and out. And I like the idea of just having an SD card that you can plug into a computer, download a file, pop that SD card into this radio, and it's all there, right? That just seems like the easiest way to get data into the micro. So, and we've got the pins, we've got the SPI bus, we might as well. There's really kind of very little reason not to. It adds a little bit of cost, but not a whole lot. So I want to do that. And all of that is possible with the upgrade to the Teensy. So that's kind of the main reason why I want to do this Teensy upgrade. And because it has enough RAM to be able to handle the frame buffer on my display as well as all the other stuff. STM32, emulating a USB storage device. So I have spent a little bit of time playing with STM32s. They're great chips. The tool chain is kind of a pain in the butt. In the interest of A, me being lazy, and B, me wanting to keep this hackable by a moderate level of community expertise, I kind of want to keep it with Arduino. And I acknowledge that that is probably going to hold me back some. STM32, I have heard since I last played with it, has better Arduino integration, but last time I used it, which was admittedly 2 years ago, last year, 1 year ago or 2 years ago, the STM32 integration was kind of rubbish. And the other thing is that the Teensy actually can probably do that, come to think of it, because it does have direct USB internally. So I might actually be able to do that on the Teensy anyway. I don't think the USB storage device emulation is unique to the STM32, is it? So that's a good point. That's another option. But for now, I'm going to go ahead and, for the board that we're talking about here, I'm going to stick an SPI header on it. And that header is going to have the pinout of this breakout module, and we'll make it there. I mean, it's easy to put a header on, right? So I'm going to make that available for micro SD card integration if we want. Okay, so the other problem, the encoders, I found something out. I learned something recently about encoders. Apparently doing 4 steps per indent on a rotary encoder is not uncommon. So I bought a bunch of rotary encoders from China, cheap rotary encoders from China, and every time you did one indent, it would count 4 steps of gray code. So at the indent, every single indent had the same output, and you had to pay attention to 4 different steps. Actually, you only had to pay attention to 2 of them, but you had to be able to notice those 4 different steps between each of the indents, and that makes it much more difficult, in my opinion anyway, to write the code, because it has to be interrupt driven. You have to make sure that you're there right at the time that it's happening. It makes a heck of a lot more sense for me to have only have 2 gray code steps between indents. Anyway, I found by reading around on Mauser last night that there are 2 different variables when you're looking up rotary shaft encoders. One of them is the number of detents, and the other one is the number of pulses. And so if you do a 24 detents shaft with 12 pulses, and that's what that 0012 is there, then that does it the way that I want it to do. What did I just make who by? Oh. So I invited Jeremy, KF7IJZ, to join me here, and apparently I just made him go buy a Logitech webcam. Is that because you don't have a webcam suitable for joining me in the Hangout? I thought you had a webcam. We've done this before. Anyway, Jeremy, are you on the stream? Are you in the chat room? You might be able to do it in the Teensy. There might even be Arduino library for it, but I haven't looked. Yeah, neither have I. Austin here is talking about the hooking it up as a USB storage device. Okay, anyway, so my preference on the encoders is to have the 12-step 24 detent encoders, because for me it makes the software a lot easier. So I went looking for those and found the part numbers, and that was part of the Mauser order that I placed yesterday. So that's actually not a whole lot for me to do here, because that's what we're already doing. Add some damn ground test points. Okay. So I was smart-ish and added an awful lot of test points. You can see them around the module here, the radio modules. Those little gold pads down, and there's some on the other side over there, right? Those are all great for hooking up O-scopes and jumper wires and being able to poke around and do things on the board when they're not working right. Except for the fact that I didn't add any test points for ground. And so I was like clipping the test lead onto the SMA connector, or like touching it onto a pin that I knew was ground or whatever. It was just, I needed to take a note to add some ground test points. Make it a lot easier for testing around things. Add some RF chokes. All right, so one of the problems I'm running into here is that every time I transmit on one of these modules, it sounds like the microphone amplifier starts oscillating. And it starts oscillating at probably about 600 or 700 hertz. It's a really kind of annoying high-pitched squeal. It's not quite 1,000. And if I disconnect not the microphone, but here, let me go back to this. Stand by. So where are we? We are here. Okay, so that's the microphone input. I have a bias resistor pulled up to VCC, and that gives the electorate microphone the power it needs to do things. You don't want to send that DC into the modules, so I block off the DC with the 1 microfarad capacitors and just send the audio into the modules, right? When I do that, if that capacitor and that pull-up are in place, this module, both of the modules, start oscillating like mad. And I don't know why. I'm thinking of adding a 10K to ground right here. Might be something so that this gets pulled down to ground. It may not be actually DC coupled to ground, or it may not be pulled down to ground, so you might be getting some weird DC in there. I really honestly have no idea what's going on, but it is making the audio on these things completely unusable. What if you split the ground for both modules so they are independent and tie together at a choke point with caps? So grounds in general is something that I need to address. For starters, I have not split up RF ground and digital ground. That is something I'm thinking of doing. Part of the problem is that these modules, I don't know which pads, if like a single pad is an RF ground and the other one is a digital ground, or if they're both just all one single ground. If you look at the bottom of the module, it's a giant ground plane. So I don't think the module differentiates between RF ground and digital ground. What I am going to do is I'm going to start putting some RF chokes on these signals. On the push-to-talk signal, the serial ports, the microphones, the squelch, the audios. Well, not the antenna, obviously, but I'm going to be putting RF chokes on all of these. So I was looking at somebody else's design of a carrier board for these, and let's see here. I'm going to load that up. So here is a carrier module that someone, there we go. Here's a carrier module that SV1AFN designed for this module. Look familiar? And his schematic, or her, honestly, I don't know. Their schematic has all these RF chokes between the pinout connector. They're 1 microhenry in series with some capacitance to ground. So like a 1 microhenry in series to the PTT and a 1 nanofarad to ground. So that's just a simple low-pass RF choke kind of thing. And I'm going to start adding those to all the signals as well, between the radios and the digital side. And I might split the ground planes up. And you don't want to capacitor couple them, but I think I do want to put some inductors in between them so that the ground coming from the radios to the digital side, there will be RF chokes in there. And the RF chokes will keep the noise out, or at least that's the theory, right? So, yeah, I got to work on that. That is going to be more of a, well, there's going to be some of that here as well. So, yeah. I was going to say it's more of a board layout problem than a schematic problem, but I think it'll be both. When you look at the data sheet for the module, are pins 9 and 10 connected to the center ground pad on the bottom, or are they separated from the center ground pad? I am not 100% sure that the center ground pad is actually a ground pad. That's part of the problem. Stand by. I got links. Where are my links? There's my link. All right, bring that one up. From the RF to digital will help, but splitting the ground for the modules will help too. So you're recommending having separate grounds between the two modules. Okay, that is a possibility as well. So this is the documentation that I have for the DRA818V, and it's just got 9 and 10, which are, let's see here, 7, 8, 9, and 10. So these two right in the middle here are ground, and those are the only grounds. You got a bunch of no connects, which is different than a ground. And this one also does not list anything about the bottom pads. It doesn't say anything about the bottom pads. I have read somewhere else that the bottom pad was a ground reference, and it was actually meant to be a, yeah, see, like P1, P2, and P3. Okay, hold on. The center ground is usually the heatsink. Yeah, this one right here, P1, is going to be the heatsink for the RF output. Tied to ground, so the ground plane is used as a heatsink. Yeah. So I did not do anything with that one on this one, on these modules. So that might be worth looking into. I don't know what P2 and P3 are going to be though. But so you're recommending. It's not saying anything about what those pads are for, are they? Can you find any documentation that confirms that? I mean, I suppose I can confirm it with an ohm meter, right? Yeah. Anyway. So lots of work to do on grounds and RF chokes and making sure everything is going around. Oh, the other thing. Hold on. Stitch all around RF ground on top layer around filters. Okay, so this was a comment that I got while I was in a conversation at the Maker Faire after parties with Kenneth and some other gentleman whose name I do not remember. But the other gentleman was an RF design person, and his recommendation is, when I was talking to him about the filters that I want to design, or that these filters here that I put in there, you'll notice how I stitched all around the filters, but that the rest of this plane isn't stitched. And his worry is that, you know, the distance from here to here is a significant fraction of a 440 signal. And so I've got this big plane hanging out in the middle of space that is not necessarily tied to the rest of the ground. So his recommendation was to stitch all the way around the outside of this, as well, and then put like a field of stitch markers or stitch vias in the middle of the planes as well, so that you don't have these grounds oscillating relative to each other. There's enough capacitance there that you got some weird stuff that you could do. Do you have a link to the datasheet for the modules? Let me look at it. Yes. Tom, Kenneth says. I will put that right there. So that's the datasheet that I have. If you've got a better link to a datasheet, let me know. Yes, you're making a Faraday cage. Yep. So I wanna stitch all the way around. So that's one of the comments that I had. What else? I was looking. Okay, let's look at these. These are neat. Unfortunately, they are not exactly what I want. So these are mini circuits. Kenneth pointed me to them, and I like mini circuits because they make these modules. It's a little 1206. That is a low-pass filter, DC to 160 megahertz. If I stick this on the output of the VHF module, let's see here. So at VHF 150, it's only 0.77 dB of insertion loss. But at, let's see here, 280 is, the first harmonic, it's at 10.6 dB of insertion loss. By the time you get up to 440, it's at 40 dB of insertion loss, or 480. 37 to 40. So anyway, this is a good little low-pass filter. And we've also got, and it's in a single 1206 component. And we've got the UHF version of the same thing. Right? Stick that as a low-pass filter on the UHF one. And that all works great. Problem is, they don't have similar high-pass filter versions of these chips. I would love to have a low pass followed by a high pass or vice versa and make a band pass out of it. But they do not make high pass versions of these. All their high pass filters are up in the gigahertz range, which is kind of a bummer because I would love to just wrap the output with these two components and call it a bandpass. Now, I can get away without doing a bandpass on, without doing a high pass on VHF. I would like to have a high pass on VHF because that'll block out like FM broadcast stations, or hell, here even AM broadcast stations. It'll give you some good pre-selection on your receiver, and it should help the performance of your receiver. But they don't make one at the UHF frequencies. Like there isn't a HFCN 430 or 420 or 400, whatever, right? The high pass filter version of this down below the UHF band, which I would really need if I intend to diplex these. What I really need is a high pass filter on the UHF side to keep the VHF transmit power out of the UHF receive path. Similarly, I need a low pass on the VHF, not only to block the harmonics that that these modules have, but also to keep the UHF transmit power out of the VHF receive front end. That's what's going to allow me to do full duplex. And so if they had these high pass modules in the right frequency ranges, I would totally be able to replace that entire bandpass filter section with just two of these little modules here, and I would be a happy boy. But they only have the low pass, not the high pass. And so I'm wondering whether it makes sense for me to just continue doing it as discrete components like this, with discrete capacitors and inductors, or whether I should cut the number of these discrete components in half, only do these as a high pass, and replace the low passness with that module right there. At this point, I think I'm going to keep it with the discrete components, mainly because I've already done it. I've done the work on that. Although, I'll be honest with you, my board, if you look there, you'll note that I just have some jumper wires, or a jumper wire, shunted across the filter section. So I don't actually have the filter on this board, because I kind of wanted to. I'll be honest with you, I don't really trust my filter design work. I'm not confident that it's good, and so I wanted to be able to test the modules and test everything else about these radios without having to second guess myself as to whether the whether the filter, if I'm having problems with the RF, is it because of the filter or is it because of something else that I'm doing? So, okay. Been going for 40 minutes, and all I've been doing is talking about the changes that I need to make, and I haven't actually made any changes itself. Stream health. There we go. Okay. Oh, neat. Any questions? Any questions on what it is that I'm trying to accomplish? And then here are some notes about how much power was being transmitted. One of the theories I had about the noise on the modules was that a lot of the early testing I did, I was powering the RF modules through the voltage regulator on the Pro Micro, which is probably not a good idea. I'm probably not supposed to be pulling that much power through that little voltage regulator. So I repeated the tests with an external power supply that's got plenty of power, and had the same problems. So I don't think that was the particular problem of those. Do you know the impedance of the traces on the RF inputs? So input is a strong term. It's an antenna connection. It's both an input and an output. The modules claim to be 50 ohms. I have no reason not to believe them. This is a 50 ohm connector. The path here is, I have not done any particular design or math to know whether it's 50 ohms or something else. But the traces are short enough, and all of the components, they're at the right angles and blah, blah, blah. I don't think it's a long enough path to get from here through all these components over to here, excuse me, that I could do anything to affect the impedance of this. This is the longest section of wire right here, with the possible exception of this one through the via. Those two are the longest sections, and there's really not a convenient way of making those any shorter. So I'm not convinced that impedance matching on this trace is going to really buy anything. Hang on. Excuse me. If you know better or otherwise, by all means, let me know. But to me, this seems like a kind of a simple, just keep the length short, and then it won't matter too much. Yeah, so these pads here, which are meant to be heat sinks, are not actually tied to anything. One of the things I should do is tie pad 19 to ground, and then put a bunch of vias here and just tie it into the ground plane underneath. But Dave, you're saying that, or David, excuse me, you're saying that I should split the grounds between the two RF sections and have them tied together with an inductor? I don't want a capacitor because I need it to actually pass current, but RF choke off the current, or the RF current. Okay. Trying to decide whether I've got the energy to get started on that. I've been spending so much time talking about it. Any questions on this so far? Any other questions? Excuse me. David and Rob have both been asking good questions. Kenneth must have dropped off because he stopped heckling me. So, Center ground is usually tied to heatsink. Making sure I didn't miss any messages. TNC. Okay, cool. Still waiting for any of the folks that I've invited to come join me. Let's see here. Have they sent me any notifications? Nope. Okay. All right. Well, let's get started then. How are you calculating the RF filters? That is a mighty fine question. Where am I? What was the link? Low pass filter. Nope. Low pass filter design. Dang it. Must have gotten pushed out of my buffer there. Let's do it this way. Low pass filter calculator. It's probably going to be one of the top ones. Shit, what? That's why. That's the one. One of these, I think. Nope, not that one. Nope, not that one either. Although that one would probably do it too. Number of LC pairs. Let's see, I think I did 3. Cutoff frequency. So let's do 146 passband, 10 megahertz, 50 ohm, 0.01, I think, because that just makes the components larger. You know, maybe this was it. So type 2 is the type I'm using because I want a high impedance. I want the antenna port to start out seeing a high impedance so that we're not trying to shunt the other power. Because if you tie them together as a diplexer, so we're using type 2. And I think these are actually the component values that we were using. Yeah, so maybe this is the calculator. So, and plug that in there. So there's the calculator. Might be good to assemble the filters on a spare board and test them if you have the tools. Yeah, the filters are going to take a lot of work, and I know that. And, oops, 440, I want 430 to 450. So that's 20 megahertz, and so I think I said this was a 40 megahertz. I think, are these the values? Yeah, 1.7 and 1.0. Yep, so these are the values. So this is the site that I was using. Either that or it's using the exact same math. But because those are the values that we used. So, yeah, that's the site. allaboutcircuits.com/tools/bandpass-filter-calculator. Might be good to assemble the filters on a spare board and test them. Yeah, there's a lot of... Yes, you're absolutely right. I'm kind of punting on the filters at this point. There's a lot of other stuff. I kind of assume that filters are a solvable problem by somebody with more expertise on this than I am. Unfortunately, UHF is in that weird middle ground. 440 is in that weird middle ground where the frequency is too low, the wavelength is too long to really kind of use strip line on a PCB effectively, but it's too high to really use components because of the stray capacitances and inductances of all your traces. So it's kind of hard. I've discovered that it's hard to do filters properly on the 440 band. And that's been kind of borne out by some of the work, all the calculations that I've been doing. Okay. So let's just go down the list. So here is my list of things to do. I'm going to keep this down on my bottom page so that I can see it. Unfortunately, you guys can't. But where's my OLED? That's I2 real-time clock display. Okay. I think I may have already come in here and fixed this. I am going to double check. So let's look. I see ground. Let's see if I can make this thing focus. There we go. See ground on the outside, VCC in the middle, or VDD, and then clock, and then data. So ground on the outside, VDD in the middle, and then clock, and then data. So I've already fixed the display connector. I remember doing that, one of the first things when I found this problem. I'm like, oh, dadgummit. So, oh, I realized I haven't actually demoed this thing to you. So on the screen, again, it's kind of hard to get this thing to focus, but on the screen it's showing the current time that it loads from the real-time clock. It is showing the those second line. God, really? Come on, focus for me. Focus. That second line there is a bunch of zeros right now. That's showing you the current status of the inputs. Yeah, it's not going to work. Dang it. Anyway, I'm hitting the various different inputs, and the display will show you what each of the inputs, what it sees in the way of inputs. And it also lists the output frequencies, or the transmit and receive frequencies of the two radio modules. So anyway, that was just a quick demonstration to show you that it's working. Oh, hey, people are chatting me. Let me I'm going to have to say that because of the placement of the pad on the bottom being right next to pins 9 and 10, going to be attached to ground internally. However, it's still a heatsink of sorts. Yeah, I can whip out a ohm meter and make sure that it's actually tied to ground. You may have to calculate the filter impedance to 50 ohms. If the filter impedance is not 50 ohms, you'll have to change the values of the filter to fit impedance and frequency cutoff. Yes, the modules are 50 ohms. My SMA connector is 50 ohms, so the entire filter should be 50 ohms on both sides. And I'm pretty sure that's what I calculated. That's what I put in on the calculator. I was hoping to find some Gerber files or something to see how the center pads may have been used, but someone else. Yeah, I couldn't find a whole lot of documentation better than that one PDF that I posted. An ohm meter will tell me whether that pad is ground or not. I think chances are pretty high that it is. Okay, so I did that one. All right, so check. Okay, switch to ground reference speaker amp to allow shared ground between mic and headphones. Okay. Where is my amp? Amp is right there. Okay, I'm not going to use an 8002. Let's see here, 4880. Nope. Of course not. Okay. Library. Nope, that's a printer. Library editor. Smitty, let's create a new one. LM4880. Yeah, yep, all of that. Yoink. Okay. 4880. So the 4880 is a audio chip, 250 milliwatts audio amplifier with shutdown mode. It's their boomer line. What? I'm home. Now what? Hold on. Jeremy's trying to join. KF7IJZ. Click on the Hangout link in Twitter DM. So we might have Jeremy joining me in Hangouts here in a second. Oh, dang it. I've been on this for too long. Haha, sorry. So the LM4880 is a little headphone amplifier. That's the one that I care about. So you will note that it has two separate amps that it's meant to be for left and right. And the amps are inherently in negative, or in the inverting mode, where you are going in on the negative input, which is good because that means I can use them directly as mixers. Now, one thing I have not done is tried to run a single mix signal into two different op-amp inputs. So I'm gonna have to have two. The signal, okay, yeah, that's going to be a lot of resistors, but we can get there. In any case, whoa, hey, Jeremy. Okay, I can hear you. Yes. Hold on for 1 second. I got some. Hang on. Yes, I can see you. So, share screen. Do you see my share screen? What do you see of me? Holding a coffee mug? Okay. Hold on for 1 second. I've got to go change. Sorry, chat room. I am going to change what the stream is seeing. And where is it? Nope. Hangout's call. There we are. Hey, everybody, look. It's Ham Radio 360's Jeremy Collinet. I have no idea what this looks like. There we go. Hold on. All right. So, Jeremy, you're not actually seeing my screen then, are you? You're not seeing it. Okay. You know what? People are not hearing you either yet. Hold on. I'm working on it. Okay, first off, give me back the chat because I need to be able to see. Chat room, I'm going to need your help to tell me when things are looking right on the stream. So, monitor built in, what I want. USB analog stereo. Hold on. Wait a second. Monitor USB DAC digital stereo. Isn't that what I was just doing? Okay. Say something, Jeremy. Damn it. Check 1, 2. Okay. No. Z. No, we're not hearing you. Try that. Say something now. Oh, for the sake of Pete. Why are you only getting... Okay. It's one of these inputs. Analog. That's not going to do it. Check again. Still you. They can see you, but they can't hear you. So you might want to bring up a copy of the stream in a different page somewhere. Monitor... Damn it. Check. Oh, there we go.
Still looking for... Can you hear me? Can they hear me?
Yes, I think they can now. More importantly, my audio is not coming in from that input. That's the important part.
Well, good.
Don't worry about having chat on the screen. Yeah, I kind of like having both on the screen, though. But yeah, I think you're right. I'm going to not... I think I prefer having Jeremy on the screen right now.
You have to bring me in.
You are in.
Actually, well, I'm not. I don't normally in a Hangout, I would be seeing stuff that you're presenting.
I know.
And I also don't even see the chat room. So it's like I'm not... Oh! Something just happened.
Oh! All right. So you apparently get to have the up the nose shot of from the webcam on my laptop.
How come I can't see the folks in the chat room? Are you? Hold on 1 second.
Yep.
Hello.
We are a professional
That's
shot
fine.
here.
I just started live streaming, so tell the internet hello.
Hello.
Okay. All right. I love you. I'm glad you made it safe. Bye-bye.
Okay.
Sorry about that.
That's okay. I had a telemarketer hit me up earlier. So why is Google Hangouts not letting me do a screen share?
I don't know. And why is Google Hangouts not showing me the chat room? I can send messages, but I don't see. Maybe, I don't know. Somebody type a message in the chat and see.
Okay, so hang on. No. Chat is not Hangout chat. Chat is YouTube live stream chat.
Chat?
Yeah, it's the live stream chat.
Oh. Remember when they used to be integrated?
No.
They were, and it was glorious.
So I go here and I say share screen, and it's like, nope.
Probably because you're already sharing screen with something. The frame buffer is already captured.
Well, that is true, but still.
Yes. If only technology worked the way we wanted it to.
I know nothing about Chromium, except that it doesn't have a memory leak when I try to when I try to do Hangouts for long periods of times. Firefox, for some reason, has a memory leak. So what I really want to do is share my screen with you.
I am going to.
Nope, I've already done that.
Your YouTube stream.
Yeah, I mean, I think that might be the best bet, and you'll just be behind by a few seconds.
That's hilarious. People on the stream are seeing 2 views of you.
Yeah, because so I can see it in OBS. The one in the lower left-hand corner down over there is that camera, which is my main webcam that's on top of my monitor. The one that's right there, actually, I can just do it right there, is that webcam. Let's see here. That webcam, which is on my laptop.
Which is the one that I'm seeing.
That you see me through, yeah. And then that right there is you.
Yes.
Okay. So, chat room people, we can hear you. I can hear Jeremy. Jeremy needs to open up YouTube or Google and something. That way he can see your screen as well. You're sharing screens with Jeremy and Skype at the moment. Yeah, I'm trying to share screens with Jeremy at Skype so he can see what's going on. YouTube Live Encoder has probably grabbed the screen already. Yeah.
Yep.
Yeah. Okay. Well, that's a bummer. I really, really, really wish that OBS had an option to output as a frame buffer. Make it look like a frame, right? So that I could send the output from OBS to Hangouts. Make it look like a camera. Make it look like a webcam. But it doesn't. That is a little awkward to have the 2 different views of me, one of which I'm looking down and one of which I'm looking up.
So I see you have a data sheet open.
I do have a data sheet open. So if you had joined us at the beginning, like the rest of class, what, you mean like the 5 minutes notice I gave you wasn't enough?
Yeah, I was on my way back from the local ham radio store, which is like an hour away. So
okay, fair enough.
Apologies.
Okay, so what are we looking at? The LM4880. Okay, well, I'm going to give a very quick rundown for Jeremy. I don't know when you can actually see this on your screen. There it is. Okay, so the version 1.0. I don't know if you've actually seen the board yet. You might have seen. What the hell? The version that I've been posting on Twitter, but there's the version 1.0 board of the SOAR radio. I've got the 2 DRA 818 modules over on this side. I've got the Pro Micro in the middle. I've got a little OLED display down here, real-time clock up here, sticking vertically out of the board. Some pretty serious bodging I've had. Oh, I should probably be doing it down here, shouldn't I? Some pretty serious bodging I've had to do right here for some audio work. Let's see here. Yeah, but otherwise it is a mostly functional radio with some pretty bad audio problems. And the problems that I've had, I'm just going to do a quick rundown. So I screwed up the power on the OLED display. I got it backwards, the power and ground, so had to fix that. The speaker amp. So it was great. The speaker amp I was using was an 8002, NS8002, which is a great push-pull amplifier. Push-pull meaning that it is driving both both sides of the speaker coil, high and low. And so it's a push-pull. And it's a great way of getting more power out of a low-voltage supply. The problem is that when you plug that into these crummy little headphones, the headset, gaming headset that I got from Amazon, it shares a ground between the headphones and the microphone, and it expects it to actually be a ground. And so I was trying to drive a lot of power directly into ground, and it caused all kinds of problems, which is the bodging that I had to do on the speaker side. So I needed to switch to a different amp that expects the output to be ground referenced. So that's why I'm switching to the LM4880, which is the datasheet that I had up on the screen just a second ago. It's a neat little chip. We'll go into that. Don't have to worry about that anymore. And then I want to add a mix of both the microphone audio from the human and the speaker audio from the radios into a line level out to send to a device for recording, for logging. So, for example, send it to your iPhone and just record the entire session and get both your microphone audio and the audio from the radio, so you can go back and listen to the whole thing and log it later. That is a chip that Kenneth talked me into putting on the board that we don't need anymore. Take it off, and then I'm going to upgrade from the Pro Micro to a Teensy. It is a much more powerful UART. One of the biggest problems that I have is that this microcontroller only has 2K of RAM, but that display right there takes 1K of that 2K of RAM for the frame buffer. So it just doesn't have enough memory on this thing to really be all that useful. The Teensy has 32K of RAM. The Teensy has a whole bunch of other stuff as well. So it's got 3 hardware UARTs on it, which will be nice. 2 of them will go over to the over to one of each of the radios, and then I'm going to expose the 3rd UART to connect to a GPS. I'm going to stay on this side of actually putting an outline on the board for a GPS module, because there are a lot of different GPS modules, and I kind of don't want to bother researching them to figure out which one is the right one for this use case. So I'm just going to put power and a serial port on an external header to put into a GPS.
So somebody would be responsible for figuring that out themselves.
At least on version 1.1. 1.2 or 2.0 later on down the line, we will probably integrate a GPS into it. But at least for now, I'm gonna kind of punt on the GPS selection process and just put a header on it and make it an external device. I also want to remove the RTC from the I2C bus because the Teensy has one built in. And GoSatWatch is telling me that AO85 is going to fly over in a minute. The Teensy also has analog audio in and out, or a DAC output and an ADC, several ADC inputs. And so I want to get audio out of the Teensy and mix it into the microphone audio going toward the radio modules, so that the Teensy is capable of generating signals that go out over the radio.
So stupid question.
Yeah.
What is the chip that's on a Teensy?
I don't remember exactly.
Okay. Is it an Atmega something?
No, it is not a Mega. It is a Cortex M4. It's an ARM chip.
Oh, fancy.
Yeah, so it's a heck of a lot more powerful.
I'm going to go research Teensies. I've never looked at them.
Teensy 3.2 is the one that I'm looking at. Either the 3.2 or the 3.5. 3.5 has some other things on it that make it a little bit easier, but it's a physically bigger module. But anyway, so
that is literally tiny.
It's about the same size as the Pro Micro.
Yeah, but still tiny.
Yeah. So I want to get audio out of the Teensy and mix it into the microphone to be able to send out over the radio. Thinking like doing APRS kind of stuff or packet stuff. It would have the ability to do that. And then also take one of the PWM outputs, which is not quite as good a quality as the DAC output, but it's still pretty good, and send that into the speaker signals so that it can, bleep and bloop and burp and beep and other things to the user as feedback to whatever the user is doing. And then I want to take the audio outputs from the radios and send them to analog inputs on the Teensy so that the Teensy can read signals coming from the radios. So that will allow us to, in the future, write some simple DSP code and generate audio to the Teensy and receive audio. Generate audio to the radios and receive audio from the radios into the Teensy, which I have no idea exactly what I'm going to do with it now, but it seems like something that would be relatively easy to add and very featureful in the future.
So you would just have the Cortex actually executing whatever that DSP is?
If we decide we want to, yeah. It's got enough horsepower, we can do it. And then I also want to add, since we have the pins and we have a hardware SPI bus, I want to add a micro SD card to it as well. And so the combination of the micro SD and the GPS will allow for things in the future like being able to just download a database of all of the satellites up there, all of the Kepler parameters and everything, and have the radio itself do all of the calculations of, I know where I am, I know what time it is from the GPS, and I know what the orbital parameters are of those satellites. So now I can tell you when the next satellite pass is going to be for a given satellite, and where to look, and what time to start doing all of the Doppler and blah, 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 blah. All of that can be done in the micro. And into the mic of the second module. Why do you want to take audio out from one module and out into the mic of the second module. Yeah, no, that's. I'm sorry if I led that on Dave McKay. Dave is asking. I apparently explained something wrong. I want the audio out from the modules to go into the microcontroller, and then I want the microcontroller to be able to generate audio into the modules. Not saying I want to be able to pipe audio from one module into the input of the other, although that would be kind of a convenient way of being able to do like a crossband repeat, but that's not what I'm trying to accomplish here. But I just want I want the audio ins and outs on the radio modules to be controllable from the microcontroller. Not controllable in the sense of switching, but controllable as in I can send audio from one way to the other. Think of like doing packet radio, doing APRS inside the Teensy as an example application for that, but conceivably we could do other things as well. Okay, so that's all the audio stuff. And then the micro SD card and the UART would allow us to do all of the GPS, not the GPS, the satellite overpass calculation stuff all inside the radio without having to use an external device to do all of that, which will be nice. I found some problems with the encoders that I purchased before. I found the kind of encoder that I like. I'm not going to go into details on this. I added all kinds of test points to version 1.0, but I didn't add any ground test points. So I had references for all of the signals, but none for ground. So I need to go add some of those. I also worry that I might be getting some RF from the radios into the microcontroller or vice versa. So I need to choke the hell out of all of the connections between the radio side and the digital side. Do all kinds of filtering and RF choking on those.
Question.
Yes.
So for the positioning, I mean, obviously you have a GPS module in there. What about a magnetometer for direction?
I will expose an I2C bus because I already have it exposed. It is something that we could add to the I2C bus or technically to the SPI bus for the micro SD card as well.
Do you know what? I mean, I'm just asking because if you're going to go to the trouble of knowing where you are and having all the calculations for the pass, I mean, the GPS, unless you are moving, does not give you a heading. So
that's true. The radio is still. I don't want to go that far yet because that is a very large rabbit hole to go down. When you start talking about, all right, now not only am I trying to calculate the time, the rise time and the set time and all the Doppler frequencies, but I am also now trying to point an antenna. Pointing the antenna is a much bigger thing because now we're talking about stepper motors.
No. Hold on. You don't have to do any of that. I'm talking about the fact if you get out in the field, you have to have some other reference to understand which direction, where are you going to be coming over the horizon, right? So the device itself doesn't know which direction it's pointing if you're holding it. So if you have a magnetometer that understands what the reference to north is, it can give you audio instructions about which direction you need to manually point your antenna. Yeah. Because otherwise, I mean, that's something that you're expecting the human being to have on board is their orientation to the, the directions.
So as Trainman points out, magnetometers suck.
Okay. Well, digital compass.
Yeah. So fair. That is not a problem that I'm trying to solve. I want to limit the scope of what I'm doing here and keep the scope creep from adding too much. We will have an I2C bus. We can put a magnetometer on the I2C bus if we want and add that later. That's good enough for me for version 1.1.
I guess though I'm just pulling on the thread that if you're going to have the thing calculate what the arcs are and give feedback about that, or am I missing something?
No, I'm not intending for it to calculate arcs. I'm having it calculate rise time and set time. So the whole point of all of that is so that it can automatically determine the Doppler shifting.
Gotcha. Okay, so all right. So you're not using any of that for positioning yet. Okay.
Correct.
I'm back on the same page.
The only thing it needs to know position for is to know when it's going to rise over the horizon and when it's going to set over the horizon.
Gotcha.
You have a compass some kind. So, okay. It's like I said, what the build that I have right now, man, The build that I have right now will allow for adding that so that we can write software, right? What I'm trying to design right now is a dev platform, effectively. I'm trying to design something that that we can do development against. And so what I'm responding to now is that Dave McKay is saying he agrees with Jeremy. If you're going to have a GPS, you need to have some kind of a compass. The GPS is to be able to figure out what time it is and figure out rise time and set times of birds. I am not yet trying to solve the problem of where do you point an antenna, though I do admit that it is a very short path between the hardware and the software that we have now to calculate the rise times and the set times to adding I would love to have a magnetometer and an accelerometer on the end of a stick, or rather, a magnetometer and accelerometer on the antenna itself with a small ring of LEDs that show you which way you should be pointing. So if it knows which direction your antenna is pointing and which orientation, how high up off the ground it's pointing. So the magnetometer will tell it, the magnetometer tells it which way is north relative to the antenna, and the accelerometer will tell it which way is down relative to the antenna. With those two pieces of information and all of the math from the Kepler parameters, you should be able to say you need to be moving your antenna that direction or whatever to kind of help the person point the antenna in the right place. All of that is a very short jump from what we have here. But
as long as you have a compass.
As long as you have a compass. But that compass would have to be on the antenna. That magnetometer and that accelerometer would have to be on the antenna, not on the radio itself, because you need it to know which orientation the antenna is in, right?
Yes.
So it needs a GPS, and the GPS does not need to be on the antenna itself, but the magnetometer and the accelerometer need to be on the antenna, and you need to have a display of some kind to give feedback to the user to say which way they should be pointing the antenna.
So do I hold SOAR like a box when I'm holding the antenna?
Honestly,
how do I use it?
My original intent, because it's supposed to be hands-off. It's supposed to be completely hands-off. So everything will be automated. So you'll either have it on a table next to you or like hanging on a necklace, on a lanyard around your neck or whatever. Just some comfortable place that you can get it set up ahead of time. But during actual operation, the PTT will be remote, either like a foot switch or a button on the handle of your antenna, or whatever. But all of the Doppler shift adjustments, all of that stuff should be completely automated for you. And so it should be completely hands-off during the actual pass of the satellite.
So I have another question.
Yes.
You talked about RF leakage in the components.
Yeah.
Since I'm ignorant of such things, how do you choke traces?
With an inductor.
So put it in line.
Let me show you. Stand by. There it is.
By the way, I apologize. I woke up very sick this morning, so I have the cold. I have a summer cold from hell.
Oh, you've got a cough button, so we're okay.
Yeah, I'm using it. That's why
I noticed.
Yes.
So this is SV1AFN, has created all kinds of modules, really cool stuff. But this is a carrier board for the DRA-818. And I was looking at I could be wrong, might be a her. I was looking at their schematic, and you'll notice that on the connectors coming in, they have all of these inductors in line with their digital signals. And kind of a common one here is the PTT, right? So it's just an inline 1 microhenry inductor with a 1 nanofarad shunt capacitor. And that's just going to be a low-pass filter, right? I've got an inductor in series and a capacitor to ground. So that the whole idea is that will block off all of the RF from any RF that might be coming in this side from the PTT, from the module, from getting out to the rest of the digital side. Yes.
There is a small human.
There is a small human.
Hello, small human.
Well, no, this is my microphone. That's one of the cameras. That's what the people on the stream are looking at me on. And then the other camera is down over here on the laptop. That's the one that Jeremy's looking at me on. Everyone, that's my daughter, Zoe.
Hello, Zoe.
She is licking the spoon of a batch of brownies.
Ooh. Lucky girl.
Yes, she is. So that's the RF choking that I need to do. Austin says hi. She says hi. So does David, although you've never met David.
I did too. You didn't tell her I said hi.
Jeremy says hi too. I think all the people say hi.
Hello.
Okay, so that's why UART to GPS and micro SD card, so that we can do all of that. And then the I2C bus exposure will allow us to put a magnetometer and an accelerometer on the antenna. You got more, Brownie?
What? I'm licking the bowl.
It's a good day. Encoders, I found good parts. Put more ground test points. Blah blah blah. Okay. Yeah. So those are all the changes that I want to make for version 1.1. But architecturally, 1.1 is going to be very similar to 1.0. Hence, a 1.1 to 1.0. When I go to actually try and package it into a case that you can carry with you and wear on a lanyard around your neck or something, that'll probably become the 2.0 version of it. Make sense?
See. So I have no idea what you've covered, and you made the mistake of inviting me to this thing. So did you already cover what the reception was of the conversations you had at Maker Faire with this thing?
I did not. No, actually, that's probably a good point. So
I have added value today.
So, well, you're just showing your stripes as an interviewer, as a good podcast interviewer, an experienced podcast interviewer.
Which is like my only skill.
No, you've got a lot of skills.
Period.
You're my Elmer for 3D printing, so don't knock it.
Yay.
So to answer your question, ooh, snazzy. What is that?
This is a DV Mega on top of a blue spot board, which is basically a USB to Bluetooth host board.
Mm-hmm.
This is a dual band digital radio that'll do D-Star, DMR, Fusion, and future other things. But I designed this case because I hated all the other designs which required a screw. And this is a single piece that everything is captive based on mechanical connections you have to make. And then finally, there's this little slip cover that just slides in, and when you plug in power for USB, it holds it closed.
Nice.
So yeah, that was 5 iterations to get everything to fit correctly. And nice. I still printed it wrong, but that's okay.
Since we're talking about print iterations.
Nice.
And this is not including the one that's actually in the car.
You've learned a lot about ABS since then.
I've learned a lot about ABS. Yeah, I don't
even... you've inspired me. Did I tell you this?
No.
So my wife and my kids have left today to go down to my in-laws. One of their uncles is throwing a Memorial Day or a weekend party. And my wife let me stay home so I could have the weekend to assemble my 3D printer, which has been sitting in a pile of parts since I got it 6 weeks ago.
Yeah.
So I'm actually, the inspiration that you've given me is I think I'm going to actually live stream the assembly.
Oh, okay, cool. Yeah, go ahead. My daughter's like, can I take one of those apart?
Well, of course.
So
you can't do anything to it your father hasn't.
Yeah, that's right. You can't do anything worse. So you're going to live stream the assembly of this? Nice.
I think so.
Awesome. Is that what you meant by I'm the one who convinced you to get a webcam, or is that the webcam I'm looking at you on now?
Oh, the webcam you're looking at me on now. I when you texted me, I was minutes from Micro Center, and so I stopped and picked it up, which was cool because it was on clearance because a newer model has come out.
Is that the 920 that you got?
This is a 920. The 922 is out. Seemed marginally better, but not $40 better. So this machine is my benchtop machine. It's a Windows. It's actually one of the only Windows 10 machines I have for all intents and purposes. And so I've never had a way to stream anything from the desk.
That's my daughter pulling apart one of the 3D prints. That's pretty cool. Show it to the camera.
Awesome.
Okay.
What has she printed so far?
She has not printed anything yet, but we've printed a few things for her. So a while ago, she was really into Harry Potter, still is technically, but she's done with the books. So I printed her a Deathly Hallows. I have the parts for a wand that we printed out, but I haven't actually glued it together yet. Yeah. So David McKay is asking, what kind of printer did you get?
What kind of printer did I get?
Yes.
So it is an Ultibots D300 SV, which actually I don't think I can put links in the live chat, but I will try. The guy that runs this is a guy named Brad Norman. He's been running it for about 5 years, doing kits of Prusa and Castle Delta designs. He took the Castle 250 and basically kicked it up a notch. And this kit is ridiculously high quality parts. So, I mean, everything is open builds, extruded aluminum frame, 300 millimeter diameter build plate. Max height as built today is like 465 millimeters. It's running a Duet Wi-Fi as the controller board, an E3D V6 hot end. Some folks in the community have already started building the mount for the Titan, which would actually give you like another 2 inches of vertical height. Sorry, the Titan Arrow. And I can't get their website to come up, but it is altibots.com. And so I went to the Midwest Rep Rap Festival, where hosted by See Me CNC. And this thing, I hate to say it since See Me CNC hosted it, but it really makes the Rostock V3 look like a plastic toy. Because it's all aluminum, it's all rigid. Really, really, really high value kit, and the print quality is ridiculous. So yeah, check it out. Ultibots, ULTIBOTS.com.
Cool. Yeah, I just have a little MakerBot or not MakerBot. God, I wish. What is it? The Monoprice Maker Select.
Yeah, you don't.
I don't. Oh, I thought
you don't wish you had.
Oh, I thought they were good.
No. If they were good, they wouldn't be changing. Yes, it is a Delta, which I'm going to try to paste the link now.
Oh my God, Zoe.
Nope, will not allow me to put web links.
All right, so I've hopefully turned up the volume a little bit so you guys might be able to hear Jeremy a little bit better. I noticed that my view level is a little low too. I was hoping that I was noticing that Jeremy's audio was kind of low compared to mine, so.
Sorry, I'll start yelling like this.
Please don't.
Can I go get a drink?
Go.
All right, I'll be right back.
He's going to go get some tea.
Well, I am, but this is my PrinterBot Plus sitting here on the table above my finger. And this is an Epson, my 2D printer.
Your 2D printer?
My 2D printer.
Not that kind of 2D? All right. While Jeremy's going off and doing that, I am going to... what am I doing? I am coming over here, and I'm going back to that. Okay, so I need to go put this into a library component on my stuff. So I'm going to draw it here. What do we do? Well, oh, shush. What? Stuff, things, places. I got the ANET A8, but haven't had a chance to build it yet and have already upgraded all the electronics except the bed and motors. I even upgraded the hot end. Nice. I am a appliance operator when it comes to 3D printing, so I think Jeremy will appreciate that more. I'll make sure he sees it when he gets back. Okay, so let's start dropping some pins. VCC. Debating whether I want this to be like a dual op amp where you put them as separate components or if I want to put it all into a single box. I think I kind of want it all as a single box. So we'll do it that. Pin number VCC is 8. Actually, that's VDD because apparently these are all FETs. Wait a minute. There we go. Ground pin number is 4. And that is an up.
I'm back.
Threats will get you nowhere. Sorry, was that my out loud voice? Again. Yeah. Austin says he's never regretted doing dual symbol parts. So I agree with you on that one, except for the fact that these parts share. Whoops. These parts share an awful lot. They share your bias and the shutdown, and power, which I guess really, I don't know. Well, I'm sorry. What did you bring over? What are you sharing?
I think he wants some of my chips and salsa.
Oh,
I'm gonna be rude and munch because somebody didn't get lunch while they were on their way home to rush to go join their friends' live streams.
Oh, I hate it when that happens.
I know, it's the worst.
Oh, that jackass. God, who would totally do that? So not only is it a cough button, it's a chip chomp button. So Austin, oh God. Okay, mute. I've got a volume control for you here too. Don't tempt me. So Austin was saying that he recommends doing separate outputs for that. So I guess I could do that with each of the things, but I kind of want to show. Shit, I don't know. Are you recommending it even for this kind of for a package like this? Yeah, I guess really it's only the bypass and the shutdown. But the fact that you've got a 15K built in is kind of something there. Yeah. I don't know. I'm open to thoughts on that, Austin. For now, I think I'm going to do a single in A, pin number 2. It's going to be a right. Yeah, especially since... Go ahead.
I was going to say, you brought me on to heckle you. You do realize that I am, because of our relationship with Autodesk, I'm legally required to heckle you for not using Eagle about every 5 minutes, right?
You are welcome to heckle me for using KiCad if you want. I may...
KiCad or KeyCAD?
I pronounce it KiCad, but I don't claim to be authoritative on that knowledge. Yeah, you're welcome to heckle me on that one. I don't want to mock sponsorships. Whenever I'm on your show, I try to. I hesitate when I talk about what program I use.
Well, you shouldn't feel obligated to do that. Be truthful. I mean, because if the day that a sponsor comes and says, "Don't talk about something" and tries to censor us, that's the day they're not a sponsor anymore.
Fair enough.
Yeah, I mean, I like Ella Craft and Kenwood and ICOM are all sponsors of the main show. They're all competitors. I mean, people use what they use. I've never laid out a board before, so I have like this much room to talk about anything.
Yeah. A little more involved than your typical op amp. Yes, exactly. So Austin is saying it's kind of hard to say in this case. These sound a little bit more involved than our typical op amp, which is absolutely the case, which is why I kind of want to put it into a single package. I might do both halves in one symbol or put the unique pins on the first ground symbol. Both halves in one symbol. Oh, like all the special pins that are common between them in one symbol. I'm kind of thinking that I want to do it in one package and actually draw some of this complexity in the package. Maybe not all the bias crap, but like these resistors to ground, and the shared common bias there, that kind of stuff. I'm kind of thinking I want to do inside the schematic diagram. And then shut down. Pin number 5. And Jeremy, to follow up on that, I respect that about you guys. I really appreciate that.
Absolutely.
But at the same time, I also don't want to go in there and say, I use KiCad because Eagle pisses me off and I hate their business model. That's not...
For that, we would probably put you in touch with our contacts as opposed to publicly.
Yeah, exactly. And it's not a fight I want to start, right? I mean, I'm not on a high horse about it, right? It's a preference. It's a decision I have made. Honestly, there are a lot of things about KiCad that drive me up the wall that I know Eagle does a much better job of. And I would be happy to come on and talk about some of those, right? But at the same time, and I don't fault anyone for using Eagle. I think Eagle is a fine product, but there are certain aspects about it that annoy me enough that I deal with the issues in KiCad on purpose.
So I have a coworker who had only ever been introduced into one package, and it's very obscure. I don't even remember the name of it, but it has an issue that when it exports the Gerbers, it actually includes the outline, like the UI of the actual program in the Gerbers. So at least neither of these applications have that problem.
No, they do not.
Yeah.
Okay, so you know what? Actually, schematic properties. Nope, I do want that. Graphic style, electrical orientation, pin. You know what? I think I'm just gonna do that. I am not gonna label these. I am going to draw them instead. All right, so let's draw, actually, first off, let's draw a box. These are not the best op amps I've ever drawn. Oh, shoot, I do not want that centered. Damn it. Crap. Fudge. Here. Get out of the way. So what I'm trying to do is I am trying to keep these pins on the hundreds. So if you look down here, you can see the location down at the bottom of the screen. Actually, I can't even tell if OBS has got that. Okay, so if you're down here, you can see the X and Y position of the cursor at any given time. And I want that to stay on hundreds. So see how it's X minus 0.5 and Y minus 0.2. I want those to stay on hundreds. I don't want to drop them on 50s. It's kind of a compulsion I have. And that is going to make drawing this op amp a little bit harder because I need to do it on that one as well. What? Oh, damn it. Fudge. Zoe from the other room just heard me and it was like, what? Fudge?
Did you ever read Tales of a Fourth Grade Nothing by Judy Blume?
No, I did not.
One of the protagonists in the book is the main character's younger brother, whose name is Fudge. The sequel to the book is called Super Fudge. Okay. It's a really great series of book for a fourth grader.
She's about 2 weeks away from finishing fourth grade at this point. So minus copy. What? Really? Minus. All right, and so, dang it. I copy that? Nope, can't do that here. Okay. Bypass. I'm not going to bother cutting those. Shut down. Bypass. Okay. And then okay. I am totally cheating on some of this.
Again, my ignorance. But all all this is effectively a line drawing.
Yep.
Like there's no logic. There's no logic, or maybe the little dots are logic for.
So these are pins, and the pins are logical. You have to drop pins on the component to say, you know, when I come in and tie a trace later on into this, that will actually tie to those pin numbers on that. So 1, 2, 3, 4, 5, 6, 7, and 8. So I've got all 8 pins there. The rest of it inside is just enough logic for the user to know what the heck's going on inside the component. I could just as easily label all of these and not do any of the line drawings. But I think this may be stupid and not necessary.
And this is on the schematic side. Obviously, you'll have to build a physical part for the layout later.
Actually, I won't, because it's an SOIC 8, so it's a standard outline. So,
cool.
So later on, all I do is I just choose SOIC 8, and as long as I get these pin numbers correct, then they will be in the right spot.
Do you know what SOIC stands for?
Small Outline Integrated Circuit.
Okay, good. Just testing.
Yes. So it is the standard for surface mount chips. Of course you knew that, obviously. All right. It is not the prettiest component I've ever done, but I'm going to run with it. LM4880. Okay. So oh, shoot. Okay. This is definitely not the prettiest component I've ever made. You know, I didn't actually think about how I wanted this to work. What are they bypassing with? They're using a 1 micro value. 1 micro. So this is a stereo amp. Do I want to do... So what I could do is... drag from there to there. Oh, that's right. That's how I was going to do it. But then I need to, damn it. So okay. So the problem that I'm running into here is that I've got this volume pot that is a single pot that I am using for volume. And the way it is setting the volume is by adjusting the feedback resistance. So I got a 4.7K coming in here, call it 5K to make the math easy. So I've got a voltage here. This is my virtual ground because it's an inverting amplifier, so consider this to be ground. However much current goes from that voltage across that 5K resistor to that ground, none of that's going to go into here, so it's all going to have to go here, which means that output's going to have to be whatever voltage it needs to be to have the same amount of current going through that 5K to go through that 10K. For the same amount of current to go through a 10K, it's going to have to be twice the voltage. So this voltage here will be twice the voltage there. That's how inverting amps work. And if I adjust that 10K, if I've got it cranked all the way up to 10K, then it's going to be twice the voltage here that it is here. If I've got that cranked down to 5K, halfway point, then it will be the same voltage here as it is here. So at 10K, it's a 2-to-1 ratio. At 5K, it's a 1-to-1 ratio. If I crank it all the way down to 0, then there will be no output here. It's a 0-to-1 ratio. So basically, that's a volume knob that it lets me go from 0 volume all the way up to 2 times. And actually, if I remember correctly, I replaced these with 1Ks, so it's actually a 10-to-1 ratio. Regardless, the point being that that pot is in my feedback path. So if I wanted to have a different set of resistors go into this one, I would need to have another feedback resistor, and it would have to be basically a dual gang pot, and I don't want to have to put that on there. The other option is for me to feed this input from that output and just do it as a follower, but then that will invert the phase because that's an inverting amp, and that's no good. Or I can just use half of the amp. I can use the other half as a mixer for the line level output, because I do want to have that line level output. So using that other amp as a mixer for that would be good. Or I can just ignore it. Joy. Hey, Bill. Bill Allen says, hello, looks like I missed a lot. Yeah, I've been going for almost 2 hours now, hour and 47 minutes. And I've got Jeremy on to heckle me, except for the fact that he's eating chips, so that he's not actually doing a whole lot of heckling. Kenneth is my pro heckler, but he had other things going on today, so.
Who Kenneth is?
Yeah.
Well, I could help you. I just leave the mic open while I eat chips.
Because that always goes over well. 470 microfarad or so. That'll be plenty. Oh, I didn't think about this too much. Yeah, I guess I've just got half of an unused chip here. All right. I'm going to leave that there for now. I think that'll be good. All right. Nope, not that one. How much longer until we're out of here? Yeah. All right. We got to get moving. We as a family have got to get moving in the next half an hour or so, and I still need to have lunch before we go. We've got some family obligations. David says he doesn't mind the crunch. He wants to hear the heckling. I am going to take a break, but there's a good chance that I'm going to be coming back tomorrow to do some more of the same. Because I want to keep moving on this and get some version 1.1 boards ordered pretty soon. Really? Damn it, David! Don't encourage him.
Delicious.
Nom noms. And the worst part is that I'm
That
low
right?
carb, so I can't even have them myself anymore.
Oh. Make sure you're getting at least 24 grams so your brain functions properly.
Well, or get your liver into ketosis and have it generate ketones so that my brain continues to function correctly.
That's how the Eskimos do it.
Yep. All right. But the reality is that I am going to have to get moving because this one, Jump, has a dance performance. She has a dance performance in a couple of hours, and I need to get lunch before we head out to go do that. You have to be there.
Break a leg.
Jeremy says break a leg. You gonna say thank you?
Thank you.
She says thank you.
You're welcome.
So yeah, anyway, we're going to come back, or I'm going to come back. I can't guarantee that Jeremy will be here. He is invited, of course, but I'll be back tomorrow, probably to spend some more time on this. Although tomorrow is the Indianapolis 500, so maybe tomorrow afternoon. I got to go find a way to go watch that because I don't have TV. I don't have
You
cable.
know, I could drive about an hour and a half and go see it.
Yeah. Never actually been in the racetrack, and then I want to do that. Well, excuse me, I'm doing that to that one. There we go.
I would say I have when I was in high school, I did Science Olympiad, and Nationals was in Indianapolis. They took us down to the track for one of the trial days, and I met both Al Unser and Al Unser Jr. and got their autographs.
Nice. Now you're just trying to make me feel jealous. Is that what you're doing?
I didn't realize you were a big IndyCar fan.
It is really the only sporting event that I care anything about. Yeah. I don't watch the Super Bowl. I don't watch sports ball. Indy 500 is something that my mom and I used to do when I was growing up. She still does it, but we just don't do it together because, she's 200 miles north of me, and it's kind of hard to do that in the same room when you're several hundred miles separated. But
you can live stream it.
We can live stream it. Yeah. No, we used to watch a lot as a kid, and I really enjoy it. And a few years ago, there was a race where I think we didn't have a single yellow flag until like 160 laps. 130 laps into the race. It was like 2/3 of the race went through before they got a yellow flag. And that was one of the most glorious races I've ever seen. It was amazing. Anyway, I got to go figure out how I'm going to stream that tomorrow because I'm a cord cutter and don't have cable or satellite or anything like that. So I got to go figure that out. But right now I got to go eat lunch and go watch my daughter do some dancing. And I will be back. I may be back later on today to keep working on this, may not. But chances are pretty good that I will be... Oh, no, that's right. I've got other plans later this afternoon. So, no, I won't be back on this. But tomorrow, I will probably be back to do this. So, Jeremy, if you're interested and available, I'd love to have you come heckle me. Hopefully, Kenneth will have some time, and he can join in too. And maybe George, if he's available, and whoever else. We'll get folks in.
Maybe I will build my printer while heckling you tomorrow then.
That sounds good. That would be fun.
Because it's far more likely that your audience will be there than if I were to post, hey, I'm building a printer very slow. Or, sorry, live streaming.
You'd be surprised, man. I have done precisely zero advertising for this. I've done promotion. That's the word I was looking for. I've done precisely zero promotion, and I've got 10 people watching me on the stream right now. So, I mean, it's now 10 is not exactly, quit my day job kind of numbers, but it's more than I expected to have. So I enjoy it. You've got a lot of followers. Might get people, especially if you announce it ahead of time so that they know it's coming.
Actually, I would just get hung because I either need to do the build video for the battery box. I actually had people at Dayton say to me, when are you going to finish the build for the battery box? And then I also need to put part 3 of my cluster video up since I have a cluster sitting here running with 0 SD cards. And it has been now for like a month.
Pretty epic, isn't it?
It really is. I'm actually working on... actually, I can show you.
I got to get moving because I got 20 minutes before we...
Never mind.
Yeah.
Never mind.
I got 20 minutes before I need to get out of here, and I need to get some food. So,
all right, go get some food. We'll see you later.
All right. You first saw who on Know How? Saw you first on Know How. Bill, I assume you're talking about me because I'm not sure that Jeremy's been on Know How. But
no.
Very cool. All right, I got to get moving. Thank you very much, everyone, for joining me. Thank you, Jeremy, for joining me. Thank you, everyone in the chat room, David, Bill, Travis, Kenneth, and if I missed anyone, I apologize. But yeah, you guys have really kind of made this whole streaming thing kind of fun and awesome, and let's go build something cool. Tell me about what you guys are working on. I always love hearing about your projects. I am Smitty Halibut on Twitter, SmittyHalibut, just like I am here on YouTube. Or you can post down below in the comments. That works out too. Yeah, hopefully I'll be back tomorrow. Today is May 27th, 2017, so I'll probably be back on tomorrow after the race. And yeah, we'll keep working on this. We'll make this radio thing happen, this SOAR radio. I'm actually really excited about how this is working out. I never actually answered your question about how it was received at Maker Faire. We'll have to do that at the beginning of the next episode. So,
Roger that.
All right, guys, I'm out. Peace.
73.
73s, everyone. Thank you so much. And okay, I'm trying to get to, there it is, OBS. All right. Cheers. See y'all next time. Be good humans. Thank you so much. And